right, so looking at our notes for 2.3, number 6, what we're going to be looking at today are how to graph functions and also higher order derivatives. The only derivatives we've looked at so far are called first derivatives. Today we're going to look at first derivatives, second derivatives, third derivatives, fourth derivatives. The only reason we really care about these higher order derivatives is because they help us when we get into acceleration. Acceleration is the second derivative of the position function. So if you know the original function is f of x for your position, f prime of x is going to tell you your velocity. V double prime of x, which is the derivative of the derivative, that tells you acceleration. There are no real applications for finding third derivatives or fourth derivatives, but you still need to understand them because they do show up a lot just, in calculus in general as far as finding higher order derivatives. So this is asking us to find the second derivative. Well, we have to know the first derivative in order to do that. This is a quotient. This is f. This is g. So we're going to have to do f prime, which is 1, g, minus f, which is x, g prime, which is 2, all over g squared. Our goal here is to find the second derivative. If I want to find the derivative again, I better simplify first because this is going to be very difficult to find the derivative of how it's written. So simplifying this, it's 2x plus 1 minus 2x over 2x plus 1 quantity squared. 2x minus 2x cancels and just leaves us with 1 over 2x plus 1 squared. That's the answer to our first derivative. We have to find the second derivative. That's what this means right here with the 2 marks, the 2 primes. So here's now my f and here's my g. So I have to do f prime, which is 0, times g, minus f, which is 1. To find g prime, I can't find the derivative of this the way it is. So what are we going to have to do to it? Foil it out. What would it be if I foiled it out? Good. So I'm going to think of it like this to find its derivative. So that derivative is going to be 8x plus 4 all over. Now, I don't really want to square this out. There's no reason to. So I'm just going to think of it as this value squared, and I'm going to, square it again. So what's it going to be raised to now? If I have this squared again to the 4th. So this is all just going to be 0 right here. No reason to FOIL that out. So I'm going to have negative 8x minus 4 over 2x plus 1 to the 4th. I could leave my answer like that as long as it doesn't simplify more. You have to think ahead. If you factor out a negative 4, would it have a common factor then? It will, won't it? So I'm going to have to go ahead and factor out a negative 4. And I'd be left with 2x plus 1. So if I have 2x plus 1 on the top and 2x plus 1 to the 4th on the bottom, I can cancel this with one of these, and I'm going to end up with negative 4 over 2x plus 1 cubed. Any questions on finding the second derivative? So what do you think this means? It says given f, and then those are 3 little tick marks, x equals this. Find f, and then there's a 4 there of x. What do you think that means? Well, no, actually, right. This is giving you the third derivative. You're asked to find the fourth derivative. It's like This means third derivative, so you would think fourth derivative, they would use 4 little tick marks. But at some point, it gets kind of hard to write all those tick marks. So they always switch it up. Once you get to 4, this means find the fourth derivative. This does not mean f of x to the 4th power, which some people think it means that. It does not mean that. The third derivative, find the fourth. So the fourth derivative then, I would want to rewrite this though so that I can find that derivative. So I can think of this as 2 minus 2x to what power? -1. And so the derivative of 2 is 0. This derivative, I do -2 times -1. That's 2. X, subtract 1. There's my fourth derivative. And then we just have to simplify that. So part of the problem with calculus is just understanding the notation. Understanding that that does mean the fourth derivative, and that does mean the third derivative. Let's look at example 3. It says, sketch the graph of a differentiable function such that f of 4 equals 2. F prime of x is less than 0 for negative infinity is less than x is less than 4. F prime of x is greater than 0 for 4 is less than x is less than infinity. On a problem like this, we're trying to sketch. Is there anything you would know at this point about what the graph would look like of this function? I like to look at this first. F of 4 equals 2. What does that mean? There's a point at 4, too. It really means that when x is 4, f of 4 just means y is 2. So at least put that point. We know that point, right? So now we're just trying to graph a function. Our function could be linear. It could be a parabola. It could be absolute value. It could be a cubic function. We're trying to figure out what kind of function it is. What does the first derivative tell us? Slope. So the slope is less than 0. So the slope is negative, right? So the slope is negative for any x that's in between negative infinity and 4. The slope is positive, greater than 0 is positive, for any x from 4 to infinity. Think of your options again. Is it a cubic function? Is it a parabola? Is it an absolute value? Is it an upside down absolute value? Is it an upside down parabola? Is it a line? Any ideas? Anybody want to take a guess? Just take a guess. What do you think? The slope has to go from negative to positive. What do you think that means? It's going to be a what? If the slope has to go from negative to positive, think it's absolute value? Well, I just did that to see if you would say absolute value. It's not absolute value because of this right here. If it has to be differentiable, what does that mean? It can't have. It can't have a sharp turn. Well, is a cubic going to meet the condition that it has to be a parabola, guys? And that's because, look, it says that our slope has to be negative. We have to have the point 42, and then our slope has to be positive, and it has to always have a derivative. So it can't be the absolute value. It can't be a cubic because then the slope wouldn't be right. Okay, you see how you got to think that through. So you'll have something like that on your homework. All right, last thing here, and this is just seeing if we understand how to use all of our rules appropriately. Given f of 3 is 5, g of 3 is 4. So that's telling me when x is 3, my f function has a y value of 5. When x is 3, my g function has a y value of 4. When x is 3, my slope of my f function is negative 4. When x is 3, the derivative of g is negative 1. We want to find h prime of 3 for each of the following. Here's what h of x equals. So I want to find h prime of 3, but first I have to find h prime of x. What do we do if we have a coefficient? You just bring it down, guys. So the derivative of h of x is h prime of x. The derivative here is 4 times f prime of x. That's just one of those properties we've talked about. For the next one, the derivative of 2g of x is 2g prime of x. So now all I have to do to find h prime of 3 is just plug in a 3 everywhere I see an x. I'm trying to evaluate this, so it's going to be 4 times, what is f prime of 3? Negative 4, plus 2, what is g prime of 3? Negative 1, so it's going to be negative 16 minus 2, or I'm sorry, is that right? Which is negative 18. Okay. Questions on that? All right, on letter B, we're going to have to take our derivative here. So h prime of x, what's the derivative of just 2? 0. What do I have to do for this derivative? Use what rule? Product rule. So I'm going to have to do f prime of x times g of x plus f of x times g prime of x. So evaluating this, f, I'm going to have to plug in 3 everywhere I have an x. So finishing it up, f prime of 3 is negative 4. G of 3 is 4. F of 3 is 5. G prime of 3 is negative 1. So just finishing, negative 4 times 4 plus negative 5 should be negative 21. All right, now doing the last one. H prime of x equals, what are we going to have to use here? Quotient rule, right? So we're going to have to do f prime of x, g of x, minus f of x, g prime of x, all over g of x squared, plus, and then what's the derivative of 3x? 3. Okay, so lots of things here, but just take it one step at a time. We want to find h prime of 3. Can I skip putting a 3 in there? Can we just go, yeah. So f prime of 3. So f prime of 3 is going to be negative 4. G of 3 is going to be 4. F of 3 is going to be 5. G prime of 3 is negative 1. G of 3 is 4, but then I have to square it, so that's 16 plus 3. So now we're going to have negative 16 plus 5 all over 16 plus 3. This would be negative 11 over 16 plus 3. What's that going to be then? 2 and 3. Yep, you got it. Good. 2 and 5/16. Okay? Any questions? All right, guys, that wraps up everything that we'll be on your quiz on Tuesday. This is a long section because it's over both the product and the quotient rules. To study, I know people think you can't study for math, but you can. You can go back and look at this packet. Any problem off the homework that you did not understand the first time, you should rework it. Because just because you watch somebody else do something and you think you understand it, that doesn't mean you can do it on your own. Okay? Let's look at your homework.